So derivative of x squared is 2x, and it gets a dx dt with it. 1 is a constant, so its derivative is just 0, equals 2y dy dt. So we can plug in stuff. The x is radical 3, dx dt is 500, equals 2 times y is 2 times dy dt. So we get 1000 radical 3 equals 4 dy dt. So if we divide, 1000 divided by 4 is 250. Your units, y was in miles, t was in hours. So 250 radical 3 miles per hour. Is that one okay? So the next one you asked about was number 6. Linear approximation. So my function is near the point a equals 0. Alright. So a linear approximation is really just like writing the equation of a tangent line at that particular point. If we want to write an equation of a line, we need a point and a slope. Okay, so I gave you that a value. That's like the x value of the point. If you plug that in, 1 plus 0 is 0, squared is 1. So my point is 0, 1. Now we need the slope. So the slope is really just the derivative of this. So the 2 comes down, inside stays the same, subtract 1 from the power, derivative of the inside is just 1. So this is the equation for the slope. So the actual slope at this point for my linear approximation, you would have to plug in your 0. So I get 2 times 1 plus 0, which is 2. So now we write the equation of the line. Plug into y equals mx plus b. Y is 1, m is 2, x is 0 plus b. So we get that b equals 1. So typically, instead of saying y equals, we use L of x for linear approximation, but it's the same thing. It's just the line. M times x plus b. So the linear approximation is 2x plus 1. So linear approximation just means the equation of the tangent line. You need a point. You have to do your derivative to get your slope, and then you write the equation of the line. So number 7 is also a linear approximation, but I didn't give you the function. I just said use the linear approximation to find the square root of 102. So we have to do a little more work here. What would be my function? Okay. My a value has to be something close to 102 that we could do the square root of. So 100. So my point would be 100, comma, if I plug a 100 in, square root of 100 is. So there's my point. We need the slope. So my function is the square root of x, so that's like x to the 1/2. So 1/2 comes down, inside stays the same, subtract 1 from the power. So that's the equation for the slope. So to find the slope when my x is 100, x to the negative 1/2, that means it's 1 over the square root of 100. So that's 1/2 times 1 over 10, so 1 over 20. That's our slope. So now we need to take these two pieces of information and write the equation. So y equals m times x plus b. So b equals 5. So the linear approximation is 1 over 20x plus 5. What am I trying to use that for? We're trying to find the square root of 102. So if I plug my 102 in there, that would be 102 over 20 plus 5. So you can, this would be 51 over 10 plus 5. So 5.1 plus 5 is 10.1. So that's our approximation of the square root of 102.
So where did you get to, like when you did 100 and then 10? Where did you get that 10 from?
I put the 100 in here, so the square root of 100.
So why is the square root dropped at
Yeah, that's what I was about to say. Like the 100, and even though when you plug it back in, it just times.
Like at the very end?
Is it because of equations like that?
Oh, right here, because my function had the square root in it. So my x was just the number under the radical. So your x is just the 102. Other questions there? Number 8. So we want the differential. So we use this when we talked about errors a lot. There's an easier way to go about this. So we talked about several options when we actually did it. The derivative of y, we can call that y prime. Haven't we also talked about how you could say that's just dy dx? So then this would be to the 1/2 power. So 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside is just a 2x. One half times 2x would just be x times 3 plus x squared to the negative 1/2. Now our goal is to find dy. So what you could do here is essentially, if you want dy by itself, all you do is multiply over the dx. And then we plug in everything we gave you. So x is 1, 3 plus 1 squared, to the negative 1/2 times dx, which is negative 0.1. So then 1 squared is 1, plus 3 is 4. 4 to the negative 1/2 means 1 over the square root of 4 times the negative 0.1. So 1 over the square root of 4 is 1/2, or 0.5, times negative 0.1. So we get negative 0.0. So all you really have to do there is do your derivative like normal, and then just move that dx over at the end and plug in everything. Is that okay with everybody? Number 9, which one do we've got A, B, and C here. So critical points, that's just the first derivative. So we want the critical points here. So to find the critical points, you do the derivative. And set that equal to 0. Okay, we could divide everything by 2. And then, what would we have to do here? Oh, we could reduce it more. We could divide it by 6, couldn't we? So if I divide these by 3. So what would we do? Approximately. I have just a handful of calculators if you need them. So 25 times 12 is what? So multiply to 300, add to negative 35. So what would that be?
Negative 20, negative 15. Dang, I had it done. I did my homework, so.
So this is 5x minus 3 and 5x minus 4. So the critical points are when those things are equal to 0. So that's when x is positive 3/5 and positive 4/5. Then I want the maximums and minimums. I said local and global, but really that wasn't what I did on my side guide. I just found the actual max and min. So let's just do our global max, our highest and lowest point on the entire thing. So we had an interval from 0 to 1. So what we have to do is take 0 and 1 as well as our critical points, as long as they fall in between those, which these do. We're plugging all of these back into the original function. So if you put in 0, you get 0. If you put in 3/5, can I just tell you, equals 16.2. 4/5 gives you 16, and 1 gives you 17. So which one's your max? And which one's your min? And that's all you have to do.
But it acts like you're local.
Yeah, so I really didn't mean for you to do that on this question.
I was just.
No. So, okay, to do that, we would have had to do the whole sine line and check the increasing and decreasing. But back in section 4.1, we didn't do that. We only did the global ones. So that is my fault. Those were poor directions. I just don't really want to do it here because in 4.3 you're doing it where you do your local ones. So that was my mistake. I need to change those directions. Sorry about that. Okay, so this is like 2x plus 1/2 x to the negative 1. So to find our critical points, we do our derivative. So that would be 2 minus 1/2 x to the negative 2. And that's like 2 minus 1 over 2x squared. You need to figure out anytime this is 0 or undefined. So if you set that equal to 0, you get 4x squared equals 1, so x squared equals 1/4, so x equals plus or minus 1/2. But what else do we need for our critical point? 0, because at 1/2 is when it's equal to 0, but the original is also undefined at 0, because that makes, you can't put a 0 into that derivative. So your critical points are anywhere your function is 0 or undefined. We are only looking on the interval 1 to 4, so we only have to check the points in that interval. So do we need to use the 0? No. Do we need to use the negative 1/2? No. So do I even use the positive 1/2? No. So all I really check, I found my critical points, and none of them are in my interval, so we only have to do the 1 and the 4. So if you plug in 1, you get 5/2. If you plug in 4, you get 65/8. So this is our min, and this is our max. So C. And this one gave us an absolute value. And any time in this class, all year long, if we've had an absolute value, we had to rewrite it to not have that absolute value. So to figure out how to break it up, you just need to know what makes that equal 0. So that is at 7/3. So we are going to have a piecewise function one thing if x is less than my 7/3, and one thing if my x is greater than my 7/3. If x is less than 7/3, so maybe a 0, if you plug that in, then you're getting a positive in that absolute value, right? So does the absolute value change anything? No. So it'd just be x plus 7 minus 3x, or 7 minus 2x. If x is bigger than 7/3, so maybe if you put in like a 5, this is negative, so the absolute value would do the opposite. So it'd be x minus 7 plus 3x. So you get 4x minus 7. So when I talk about the derivative, we have to do the derivative of each of those. So the derivative of the first piece is just -2. Derivative of the second piece is 4. Does that derivative ever equal 0? -2 is never 0, 4 is never 0. But we do have a critical point. Critical point is anywhere the derivative is 0 or undefined. When is this derivative undefined? At 7/3. Because if you think about the absolute value graph, there's a corner there, and we don't have a tangent line at a corner. So then to find our max and min, we have to check the endpoints as well as that critical point. So if you put in a 1, you get 5, 7/3 gives you 7/3, and 5 gives you 13. So this is our max.